All right, so part of Chapter 3, Section 2 deals with horizontal and vertical lines. So we're going to look at this first example. We're asked to graph A, which is the equation y equals 2, and B, which is the equation x equals negative 3. So what you'll notice in both of these equations is there's not two variables. There's not an x and a y. There's either just a y, as is in the case of A, or just an x, as in this case here. But if we're asked to graph it on a coordinate plane, which contains an x and a y, then we need points. We need x's and we need y's. So going back to the method that we've been discussing with using tables, we can graph each of these in that way. So starting with A, if I consider a table of x and y values, and remember a table of values for any equation is always a pairing of an x and a y such that those pairings satisfy the equation. Well, here in this equation, y is 2. So no matter what, y has to be 2. It really doesn't matter what x is. If x is negative 1, what's y? Well, it's 2. It has to be. It says that's what the equation is. If x is 0, again, y is 2. And then finally, if x is 1, y is 2. All of these points satisfy the equation. All of these points are solutions of the equation, and therefore when we plot them on the coordinate plane, the point negative 1, 2, or the point 0, 2, which is here, or the point 1, 2, all of those points are solutions on the equation, or of the equation, and any point actually lying along this line is also a solution of the equation. So anytime you have a y equals some number equation, it's always going to result in a horizontal line. Now if we look at B, this equation is an x equals equation. So once again, if we consider making a table, the equation tells us x is negative 3. No matter what, x is negative 3. So x is negative 3, y might be 0. X is negative 3, maybe y is 1. X is negative 3, y is negative 4. Okay? Really, it doesn't matter. As long as x is negative 3, then any point containing an x value of negative 3 is a solution to that equation. So again, the point negative 3, 0, that's a solution to the equation. The point negative 3, 1, negative 3, 1 would be a solution. The point negative 3, negative 4, all of these points are solutions to the equation, and actually any point along this line is a solution to the equation. So anytime you have an x equals some number equation, the result is going to be a vertical line. Because along this vertical line, x is always negative 3, no matter what point you stop at. This point right here is negative 3, negative 2. This point up here is negative 3, 5. As long as x is negative 3, it's a solution to the equation. So in general, when we're talking about horizontal lines, or rather equations of horizontal lines, they are always in the form y equals, and we'll just call it b, where b is any real number. Okay, oh, let me move that up for you. So equations of horizontal lines are always going to be in this form. Y equals b, where b is any real number. So y equals 5, y equals negative 6, y equals 10. Anytime you have an equation in that form, you're going to get a result that is a horizontal line. Equations of vertical lines, so lines that go up and down, are always going to be in the form x equals some number. So let's just say a. X equals a, where a is any real number. So whether x equals 0 or x equals 6 or x equals negative 1, you're going to get a result that is a vertical line.